In 2017, Earth encountered something truly alien, a visitor from beyond our sun, moving faster than anything we had ever seen. At first, it looked like just another comet, a faint streak of light drifting quietly across the sky. But when scientists traced its path, they found something that shouldn't have been possible. As it moved away from the sun, instead of slowing down, it sped up. Every calculation, every model said it should lose speed, yet it didn't. It broke the rules of gravity, a silent defiance written across the void. That mysterious traveler was called ʻOumuamua, the first messenger in the Hawaiian language. And now, 8 years later, it's happening again. Another object. Faster, brighter, stranger, approaching our sun. The question isn't whether it's real. The question is, what message does it carry this time? Astronomers called it Oumuamua, the first interstellar messenger ever found, a name that feels even more fitting now. It entered our solar system, moving at nearly 87 kilometers per second, more than twice the 42 kilometers per second needed to escape the sun's gravity. When it passed behind the sun and began to leave, something even stranger happened. Instead of slowing down, it sped up. Every known law of motion said it shouldn't. Yet the data didn't lie. Its brightness also flickered, growing bright, then dim every 7 hours. That meant the object wasn't round. It was long, or maybe wide and flat, slowly tumbling through space. Two shapes fit the data: a slender, cigar-like shard, or a thin, disc-shaped fragment turning in or in. And yet it had no tail, no halo, no coma of dust or gas like a comet should have. It was silent, smooth, reflective, and it defied everything we thought we knew. If it wasn't rock, and it wasn't ice, then what could make it move? 2 years later, another wanderer appeared, Borisov. Unlike ʻOumuamua, this one looked familiar. It had a tail, a glowing coma, and the unmistakable breath of a comet coming to life. As it neared the sun, frozen water, H2O, and carbon monoxide began to sublimate into space, forming a vast cloud of gas and dust. Everything about Borisov behaved exactly as physics predicted. It was bright, reactive, and perfectly natural. For scientists, it was a relief, finally. An interstellar visitor that made sense. But that calm wouldn't last long. On July 1st, 2025, telescopes from the Asteroid Terrestrial Impact Last Alert System, or simply ATLAS, caught sight of something extraordinary. At first, it looked like a faint moving dot, another rock wandering beyond Jupiter. But the data said otherwise. Its path, its speed, its angle, none of them belonged to our solar system. Astronomers labeled it 3I Atlas, the third interstellar object ever discovered. When we first spotted it, the object was still 4.5 astronomical units away, about 6 to 170 million kilometers from the Sun, near Jupiter's orbit. Yet even from that distance, its reflection was unmistakable cold, bright, and fast. This time, we're not catching the aftermath of a passing ghost. For the first time in human history, we can watch an interstellar visitor as it approaches the Sun. When astronomers traced the path of 3I Atlas, they noticed something remarkable. Its origin didn't point to the familiar plane of our solar system. It seemed to be coming from far above it, from a place few objects ever come, the thick disk of our galaxy. Our Milky Way is layered like a vast cosmic ocean. The thin disk is where most stars are born young, bright, full of life. But above and below it lies the thick disk, sparse, ancient, and quiet, a realm of relic stars that formed billions of years before our sun existed. 3. I Atlas appears to come from there, a region older than our solar system itself. If that's true, then this object has been drifting for more than 7 billion years, crossing the spiral arms of the galaxy like a silent message carried by time, a fragment from an age before Earth, before the sun, before memory itself. The closer astronomers looked, the more enormous 3I Atlas appeared to be. Its glowing coma spans nearly 20 kilometers across, and at the center, the solid core could measure anywhere between 5 and 11 kilometers wide, or about 7 miles. That makes it 10 times larger than Oumuamua, and nearly 5 times the size of Borisov. But what truly stunned scientists wasn't just its size, it was its speed. 3. I Atlas is moving faster than any comet we've ever recorded at that distance from the sun. And as it races inward, sunlight begins to stir its frozen surface, triggering a process known as sublimation. Instead of melting into liquid, the ice turns straight into gas, just like frozen carbon dioxide turning into vapor. The result is a natural engine jets of invisible gas, pushing this ancient traveler forward through space. 3. I Atlas won't fly straight into the solar system, it's cutting across from the side. Like a cosmic T-bone collision, its trajectory slices across the planetary plane at a steep angle, a path no comet from our system would ever take. On its way inward, it will pass near 3 planets: Mars 28 million kilometers, Venus 97 million kilometers, Jupiter 53 million kilometers, and even at its closest approach to us, it will still be about 24 million kilometers from Earth, roughly 50 times the distance to the Moon. But here's the eerie part 3. I Atlas is coming from the direction of Vega, the brilliant star in the constellation Lyra, 14,000 years ago. Vega was Earth's North Star, the ancient pole light our ancestors once used to navigate. And now, across cosmic time, it sends us a visitor. Even stranger, our entire solar system is also moving toward that same direction, which means we're not just being visited, we're colliding paths in motion. In October, 3 Atlas slips behind the sun, disappearing into the glare, lost to our view for 2 long months. There will be nothing, no light, no signal, just silence. The telescopes will wait, the data feeds will run empty. Across the world, astronomers will stare at a quiet patch of sky, wondering what's happening behind that burning wall of light. Then, in December, the messenger returns. A faint signal, at first a glimmer breaking through the noise. Slowly, it grows brighter, closer, alive again under the gaze of the sun. What will it look like when it reappears? We can't build and launch a new probe fast enough to chase 3I Atlas. By the time it left Earth's orbit, the visitor would already be far beyond our reach. But we already have eyes out there. Around Mars, the ESA Mars Express and the Trace Gas Orbiter are preparing to turn their instruments toward the incoming object. In early October, Mars Express detected a faint glimmer of light, a reflection believed to be from 3I Atlas itself. And farther out, orbiting Jupiter, the Juno spacecraft may hold an even better vantage point. If Mission Control dares to try, Juno could perform a slingshot trajectory, breaking from Jupiter's orbit to intercept the comet as it passes by next spring. It's a long shot, but not impossible. If Juno can capture even a single image, humanity might finally have its first close look at an interstellar traveler. Some scientists believe 3 Atlas and even ʻOumuamua before it might not be alien at all. They suggest it could be a shard of frozen nitrogen, a fragment torn from the surface of a shattered world. Nitrogen ice reflects sunlight brilliantly, but sublimates, invisibly turning directly into gas without forming a visible tail. In other words, a ghost comet, bright but silent. A piece of a world long gone, drifting across interstellar space for billions of years. Unless, of course, someone built it that way. Who's kidding? Probably. Every photon bouncing off its surface carries the story of another star system. Within that light are clues about the chemistry, the age, the radiation that shaped a world beyond our sun. For the first time in history, we can study interstellar ice, dust, and cosmic rays in real time, not from theory, but through direct observation, whether it's natural or not. 3. Atlas is teaching us something our textbooks never could, that the universe still holds surprises far beyond our reach. Every orbit, every fragment, every reflection. A lesson written in the language of the stars. Maybe it's just ice and dust. Or maybe it's a mirror reflecting how little we truly understand. The universe doesn't whisper, answers it, offers questions, carried by wanderers like this one. As the signal fades and the static hums, we are reminded that mystery is not a flaw of science, it's the reason we keep looking up. If you want to witness its return this December, subscribe and stay on watch with us.